Hello, welcome. This is Kamau, and this is Back to School for Dummies. Yay! So, this week we're focusing on math. Each week we alternate. So, last week we looked at the parts of speech in English language, and this week we're going to do an introductory lesson in mathematics. So this series, even though it's for everyone, it's particularly geared towards adults who are doing remedial math and English. So this is for adults who, for whatever reason, and we don't need to know the reason, for whatever reason, you missed out on the basics when you were coming up through school. You missed out on the fundamental concepts in mathematics and English, and right now you're interested in progressing, you're interested in going back to the basics. And this is why our series is entitled Back to School for Dummies. If you know that you're a dum-dum and you understand what needs to be done to catch up with the rest of the pack, you have no qualms in accepting that you need to go back to the nitty-gritty, you need to get back to the foundation. And this series is all about asking dumb questions. Don't be afraid to ask dumb questions. That's what we're all about, and I'm encouraging you as adults, if you are watching and you're interested in going back to the basics and learning math from the roots up, working your way up to the top of the tree, this is the place for you. Get your book, get your pencil, come on over. We're doing the signs and the symbols that are used in math. All right, so these are the signs and symbols that you're going to be seeing as we go along. And so you need to understand what they mean. This is where we need to start, right? You have to know the different signs and symbols that are used in math. So when you see them as we go along, you can say, oh, yes, I remember what that is. I remember what Kamau said we're supposed to use this for. All right, so we're going to share our screen and we're going to go one by one through the basic signs and symbols. Jot them down, make notes as we go along. If you have any questions, type them in the chat. Even if I don't answer immediately, I will come back. I will be prompted if you post a question or comment. I will be prompted and I will most definitely come back and respond so that you can clear up any issues that you may be having. Any dumb question that you have, I want you to ask. So I'm going to share the screen now so you can see the presentation that I've made for you. And we're going to go through. So there we have on the screen, that's Dum Dum. And you will be seeing Dum Dum in weeks to come. So that's our puppet that we're going to be using as our learning aid in these sessions, right? So for the time being, you're going to be seeing Dum Dum in the presentation. And then later on, you'll see him in person. So let's go back to school for dummies, and the topic is signs and symbols used in math. All right, so these are the basic signs. And really we should, well, we're going to be doing different sessions on numbers, types of numbers, But remember, numbers are symbols that are used in math, right? Don't forget. You write them down, they are symbols, they represent different quantities. Even the quantity that we call nothing is represented by a symbol, 0. All right, so here on the screen we have the 4 basic symbols of arithmetic. So arithmetic has to do with computation, calculating, and the 4 basic symbols of arithmetic are multiplication, division, addition, and subtraction. So here we have the multiplication symbol, we have the division symbol, the addition or plus symbol, which looks like a cross, and the minus symbol, which is just a short horizontal line. The multiplication symbol looks like an X. The division symbol is a horizontal line with 2 dots, one above and one below it. And we're going to go into each one now and talk about when we use these symbols. So the addition symbols, and these are other words that you might hear being used, which prompt you to know that you're supposed to add. So if you hear the word add or find the sum of, or what is the total, how many all together, this plus that, so this quantity plus that quantity, or how many in all, these are prompts to let you know that more than likely you're going to be adding. So if you're asked to calculate the full amount due, or how many persons or how many items in all were there, these are cues and clues that let you know some kind of addition, summation, total, right? That's the idea. So everything being considered together, that's addition, and that's the plus sign. Subtraction, it could be said that addition and subtraction are opposites. So in addition, more things are coming on. In subtraction, you're actually reducing or taking away from what was there before. So if you're asked how much is left, or how much taller one thing is than another thing, how much longer or even shorter one thing is than another thing, or take away, if you're told to take away this amount from that amount, or by how much does this one exceed that one? If you are 20 minutes late, what time should you have started? So if you are given a time to say you are late, so you know that you should have started before, right? So you would have to subtract that number of minutes from the present time to see what time you should have started. So whenever you see words like subtract, how many remain, what's the difference? So in maths, when you are asked to find the difference, you are being prompted to subtract. When one thing is less than the other thing, you would subtract to get the smaller quantity. One thing is fewer than, right? Or how many more is this one than that one? You're still expected to subtract. So whether you're asked how much less or how much more, you're actually going to need to subtract, and then depending on whether you want the bigger one or the smaller one, then you would determine. Minus, so these are words that indicate subtraction. Reduction, you're reducing one thing by another thing. Minus, take away, find the difference. These are cues and clues that you're doing the operation of subtraction. And remember, all of this so far comes under simple arithmetic, right? One of the 3 R's that used to be taught: reading, writing, and arithmetic, the 3 R's. Of course, we know they're not really R's, but they sound like R's. So, multiplication. When you're asked to find the product of 2 or more numbers, if you're asked to find this one times that one, 3 times 4, 8 times 10, or twice a number, if you're asked to find twice a number, you're being asked to multiply by 2, or thrice, 3 times a number. Or if you're asked to double a number, then you're asked to multiply that number by 2. Sometimes when you're asked to find the total, you're also being asked to multiply. Could be addition or multiplication, depending. If you say one number multiplied by another number. So usually with multiplication, it's a short way of doing repeated addition. So instead of adding 4 groups of 7, you keep adding 7 each time, or you keep adding 4 7 times. You just multiply the 4 by 7. So whenever you keep adding the same quantity over and over and over, the shorter way is to just multiply the original number by that quantity that you keep adding over and over. 5 groups of 10, 6 groups of 5, and so on. Those are multiplication operations. How many in all if a certain number of sets contain the same number of elements each? So if 6 sets each have 3, each has 3, then that's a multiplication operation, 6 times 3. Or if 3 sets each has 6, 3 times 6. And multiplication and addition are what we call commutative and associative properties, meaning it doesn't matter which two you do first, or given to which one you do first, you will get the same answer. This applies to multiplication and addition. So if you're saying 3 plus 6, you will get the same answer as 6 plus 3. Or 5 times 9, same answer as 9 times 5. Or if it's 3 numbers, 2 times 5 times 8 is the same as 2 times 8 times 5. Same for addition. So multiplication and addition follow the commutative and associative properties of arithmetic. Division and subtraction do not. It matters the order that you divide and subtract. When you see words like divide, find the quotient, how many times does this thing go into that thing, split something equally or share something equally, distribute something equally, or how much does each person get, these are indications that you're about to do a division operation, right? How much of this thing can hold into that bigger thing? Or how many times can this be cut from that? How many sets of this are contained within that one? How many times can you fill this cup from this bottle, right? So division is a short way of doing repeated subtraction. Instead of subtracting 4 from a number several times, you can, and then counting how many times you're able to subtract it, you can simply divide the number by 4. All right, so far so good. We have covered the basic operations of arithmetic. So let's look at other symbols. So this symbol equal to. two short lines, two short horizontal lines over each other, this quantity on the left is equal to that quantity on the right. And if the lines are curvy, wavy, one atop the other, it's approximately equal to, meaning roundabout the same, right? Maybe not exactly the same, but roundabout the same. This sign here is greater than. The quantity on the left is the bigger quantity, and the quantity on the right is the smaller quantity. So 4 is greater than 1. This sign here is less than. So for the greater than, we could say the number that is in front of the open mouth is the bigger number. For the less than, so the number on the left now would be in front of the closed mouth, and that is less than the one on the right. Here we have greater than or equal to, where we have the greater than sign and the line beneath it. When something is greater than or equal to, it means it can be that thing or more. So at least that thing. The original number is included in the possibilities. So if it's greater than or equal to 4, it can be 4 or more, not just greater than. If it's greater than 4, 4 is not included in it. But if it is greater than or equal to 4, it is 4 and all the numbers bigger than 4. If it's less than or equal to 10, then it can be 10 or less, right? Not more than 10. 10 is included in the set and all the numbers less than 10. If it's just less than 10, then you would not include 10 in the set. And that's the difference between having the equal to sign below those. Make sure you're jotting these down. You're going to need to remember these as we go along. So that's why I'm starting with the basic signs and symbols. Here we have brackets, otherwise called parentheses. And the square bracket usually is used when you're going to have other operations within parentheses. So the parentheses usually come within the square brackets if you have another operation that you have to work out before the bigger operation. That's how they're usually used. And we follow the order of operations, which we're going to be doing also as we go along. Probably our next math class will be order of operations, and the order of operations tell you which operations you need to work first before you work other operations. And this is very important, or your answer will be incorrect if you don't know the order of operations to follow. In order of operations, we will work the parentheses first, and the powers before we go on to the arithmetic, the basic arithmetic operation. So we multiply, we work the parentheses, whatever is inside the parentheses, we multiply and divide before we add and subtract. The curly brackets are usually used in set notation, where we're listing the elements of a given set. So here we have the line segment AB. This is in when we're doing trigonometry or geometry, and we're labeling our line segments from point A to point B. This is a part of set notation where we have this is not an element, or it does not belong to the set. So usually, when you have a line going through something, it means not, or does not, or do not do it, or it does not belong. This is a symbol for angle. So the angle would be within here. And this is a special angle, which is a right angle, two perpendicular lines forming a 90-degree or right angle. Sometimes in math, operations, you will see plus, minus together, one above the other, plus or minus. This usually indicates that you are to do both operations separately. So you are to add as well as take away. You might also see it in front of the answer for square roots, because the square root of a number is both positive and negative. The square root of 16 is positive 4 as well as negative 4. When you multiply them by each other by themselves, you will get back 16. So 4 times 4 is 16. Negative 4 times negative 4 is also 16. So the square root of any number is positive as well as negative. So this is one case where you will see the plus or minus. Also, for example, in the quadratic formula, you will see the plus or minus, and at a certain point, you would have to branch off and work the addition and the subtraction, in which case you'll end up with two different answers, right? Here we have not equal to. So just as we have an equation where something is equal to something, on a quantity on the left is equal to the quantity on the right, it could also be not equal to. This is the square root symbol. And when we're finding the square root of a number, we're asking ourselves which number, when you multiply it by itself, you get the original number that you're trying to find the square root of. So if you're trying to find the square root of 81, you're asking yourself, which number, when I multiply it by itself, I get 81. And just as I said before, the square root of a number is positive and negative. So it will be positive 9 as well as negative 9. Those are the square roots of 81. This is the symbol for percent. And percent means out of 100. It's expressed out of 100. Per, out of, cent, 100. So 80% means 80 parts out of 100 parts. And we're going to be doing all of these things as we go along. You're going to learn how to work out percentages, how to do decimals, how to find square roots, how to do sets and algebra and trigonometry and all of these delicious things. However, we have to take it in strides. We have to remember that there's a lot to cover. And if you have been missing out all this time, then you really need to start from scratch. Be humble and go to the very beginning. Take your time. Don't allow yourself to become overwhelmed. It's a lot to take in. You have to practice. So every week when you do the sessions, go back, look at your notes, practice, revise, watch some more videos, rewatch this video, and keep yourself up to speed, because there is a lot to cover. But there's no need to feel daunted or overwhelmed. You can do it. You have to become a learner for life. You have to understand learning is a lifelong event. We are all learners of life, and we have to commit ourselves to be learners for life. A lot of the adults who come to me asking for me to teach them and take them from the basics, many of them don't carry through. They start off with a lot of enthusiasm. You know, they get their books, they get everything ready, and they're raring to go. And then a short while after, they lose the momentum, they lose that drive. They become overwhelmed when they see how much there is to cover, and especially when they see that they're not grasping even the basic things. They allow themselves to feel daunted and to give up. But I am encouraging you to be steadfast, take your time, ask dumb questions, and commit yourself to learn this for life. So here we have symbols. This is the infinity symbol, right? And infinity in mathematics, infinity itself is not a number. Infinity represents an idea that numbers never end. So there is no number called infinity. Infinity suggests to us that numbers continue in both directions. They continue in the positive direction and the negative direction forever, because you can always add another number, you can always subtract another number. So there is something called positive infinity, and there is something called negative infinity. Never ends. As far as we can conceive, numbers keep going, numbers keep getting bigger, 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 smaller, smaller, smaller. The integral is a topic in math that allows us, and it actually, integration works alongside differentiation in calculus, and they allow us to do some really neat things in terms of working out the areas on the curve and so on. So this is for when you've mastered the basics and you're going up there now into the more advanced levels of mathematics. The summation symbol indicates that we're finding the sum of a set of numbers in a series. Equivalent to, this is also the symbol for equivalent to, in addition to the wavy lines that I showed you earlier. And when things are equivalent, they are almost the same, or they can be considered along the same lines. This implies, so remember that these symbols are actually the language of mathematics. Mathematics has its own language, just as most other disciplines. They have their jargons, they have their symbols, they have their language. It's the way that mathematicians communicate with each other efficiently and quickly to get ideas across to each other. And when you're writing, when you're doing your working out in mathematics, it is best that you write it as if you're writing a paragraph. What I mean by that is, when you're showing your working out step by step, you use symbols like therefore, this implies that, and so on. So the person who is marking your paper can understand the logical steps that you're taking to go from one thing to the other. When you do it like that, your examiner can see, or your teacher can see, that you are reasoning out in your head the logical steps towards solving the problem. So this symbol means for all things being considered. This symbol here, it indicates that something or a set of things belong to a particular set. So this is part of set notation. This thing is an element of the set of whatever. And we saw earlier where we drew a line through that, which indicated not an element of. All right, so as we go along, this symbol here that looks like an N, a very stylish N, it is called pi, and it's a symbol that you're going to meet a lot in mathematics. It's actually a Greek letter, right? It's a letter in the Greek alphabet. The name of the letter is pi. In mathematics, this symbol is used to represent a particular quantity. And this quantity is 3.14 in terms of decimal, or 22/7 in terms of fraction. Pi represents the relationship between the circumference and the diameter of every circle. And what I mean by that is, if you take any circle, whether big or small, and you divide the circumference or the distance around the circle by the diameter, or the distance across the middle of the circle, you will always get 3.14 or something very close to that. And that quantity, we call it pi. Pi is used, therefore, to work out, given the circumference, you can work out the diameter, or given the diameter, you can work out the circumference, and a number of different lengths and values that pertain to the circle. Even so pi, we use pi in geometry, we use pi also in trig, right? And it's a very useful number. You're also going to encounter other standard numbers that we use symbols to represent. One of them is E, and so on, as you go along in your study of mathematics. The circle with a line drawn diagonally through it is one of the symbols that represents the empty set or the null set. And the empty set contains no possible members. So this is one of the symbols used. The other symbol would be two curly brackets with nothing in between them. Here we have array. So array has one endpoint and the other point goes to infinity. Actually, right, you can't see the endpoints, but that's what it is. All right, we're almost there. So what we have here now are roots. So we have the cube roots, the fourth root, and you can actually have any number here: fifth root, sixth root, 10th root. The root is the opposite of squaring or cubing or so on. So for example, if I multiply a number by itself 3 times, if I multiply 2 times 2 times 2, I'm going to get 8. 2 times 2 give 4, 4 times 2 give 8. So 2 cubed give 8. The reverse of that would be the cube root of 8 is 2, right? 3 times 3 times 3 gives 27. So 3 cubed, 3 with a little 3 at the top. Then the little 3 at the top to the upper right hand side tells you how many times you're multiplying the number by itself. And of course, we're going to do each of these in more detail, right, as we go along. How many times you're multiplying the number by itself. So 3 to the power of 3, or 3 times 3 times 3 gives 27. The reverse of that will be the cube root of 27 is 3. Likewise, if I raise 2 to the fourth power, if I multiply 2 by itself 4 times, 2 times 2 times 2 times 2, I'm going to get 16. So the fourth root of 16 is 2, and so on. So any number can go here. And these are operations that you can do if you have your calculator. However, right now, I would encourage you not to rely on your calculator. This is the time for flexing your brain, using your brain power. This is the time for doing some mental arithmetic. This is the time for working things out in your book from scratch, right? Later on, when you probably have the constraints of time, you're in a test or so on, and you have to rely on your calculator, then you can use it. But then you would have known that you are able to work these things out on your own. For those who are just starting back to learn math, don't use a calculator at this point. You have to retrain your brain to take things from first principles, as we say, from scratch, learn how to do the calculation step by step. So mathematics has its own language. Yes, mathematics has its own language, and it's a beautiful language. Mathematics is a language of logic. Mathematicians use signs and symbols to communicate quickly and efficiently. You should practice these symbols, practice drawing them, practice writing them, try to quiz yourself or ask someone to quiz you as to what these symbols mean, because you're going to need to learn them as we go along in order to do the calculations, in order to reason out the logics. Remember, we just said mathematics is the language of logic, or logic is the language of mathematicians. And just like any language has its symbols, so the English language has the English alphabet with symbols, which we call letters, and they are used to represent sounds. And every language has its alphabet, and we put these together to convey meanings. We form words and phrases and sentences and paragraphs to convey meanings. It's the same thing in mathematics. We have mathematical sentences. If I say 2 plus 3 equals 5, that's a mathematical sentence. That's a statement. I will use symbols to make that statement. So I will write the symbol for 2, I will write the symbol for plus, and the symbol for 3, and the symbol that means is equal to, and the symbol that represents the quantity 5. All of those are symbols that I'm using to draft the mathematical sentence. Very simple mathematical sentence, and we have more complex mathematical statements as we go along. But you need to understand that this is a language, and it has its rules, it has its exceptions, it has its codes, just as with any other language. It is a beautiful language, and you must learn to master it so that you can communicate. You're mathematicians. Yes, you may have been derailed, right? Remember, we're speaking to adults mostly for this series. Anyone can benefit, of course. If you're in grade 1, grade 2, grade 3 coming up, of course you can benefit from these sessions. The Back to School for Dummies is specifically geared towards adults. So if you know that, maybe you slacked off back in the day, you didn't pay attention, you were warned by the teacher, you were warned by mom, you were warned by dad, you didn't listen, you did your own thing, that's okay. You don't need to blame anyone, you don't need to make excuses. You just need to understand that right now you need to go back to the basics, and you need to have the discipline, the humility to stick to it this time. Don't give up this time. And I am here to hold your hand. I'm here to guide you along. And this is the place for you to ask your questions. If there's anything that I have explained in this lesson that you're still not clear about, write your question in the comments below. I will come back and respond. And look out for our lesson for next week, where we're continuing with English language. So remember, in the previous English lesson, we looked at parts of speech. In general, we looked at the 8 parts of speech as a session. And what we're going to do following this is to break down each part of speech and devote a video to each one. Because remember, if you remember that video, we said that each part of speech can be broken up into different sections, right? We have different types of nouns, different types of pronouns, different types of adjectives, and so on. Each one deserves a video of its own. And that's what we're going to do next week. I believe we're going to look at the noun and break it up into the many different types of nouns that exist. So until that time, I will see you, and looking forward to having your company. Remember, stay on board, stay on track. Don't allow anything to derail you now. Don't allow anything to convince you that this is not worth it. It is very much worth it. You are worth it. Your education is important. All right, so take care. This is Kamau. See you then.